Okay, hi guys. In this video we're looking at properties of numbers. We're going to be looking at the number laws. Your learning goal is to demonstrate and use the number laws to solve problems and apply that to mental strategies, so using mental strategies. By the end of this you should be able to correctly use the commutative, associative and distributive law to solve problems. So make sure you write your learning goal down. Thanks guys. Alright, so commutative law. So this is like a definition of what it is. Numbers can be added or multiplied in any order and the answer will be the same. So this is like the example when I get you guys to do timetables. We have like 3 times 2 or 2 times 3. The order does not affect the answer. So just to note, subtraction and division are not commutative. So let's have a look at this example. Here you've got a sandwich, $4.50, $3.20 for a box of juice, and 70 cents for a piece of fruit. Now that can be written as a math expression of like total equals $4.50 plus $3.20 plus 0.7. Now I can put them in any order. It doesn't matter if I put $4.50 then 70 cents then $3.20. They will all equal the same thing, won't they? So $3.20 plus are still gonna give you the same total. So that's something that we can do. So we can arrange it so now, because we know that addition and multiplication are what we call commutative, it doesn't matter which way you organize them. So I'll just bring that back up a bit. It doesn't matter which order. I can look for things like rainbow facts. So your rainbow facts might be able to help you here. And that just means numbers that add to 10. You might be looking for doubles or things that can help you out, or reducing rounding. So when I add numbers together, I try, especially mentally, I try not to have carryovers. So I would use the strategy of adding these two numbers together first. So I would add those, because you've got the 70 and the 20 and the 50, and that's going to give us 70 cents there, plus the 4 and 3 gives us $7.70 plus 0.7, and I know that 7 plus 7 is double 7 is 14, so that's going to be 40 cents, plus the extra dollar gives us $8.40. So I've just talked through some like a mental strategy there. It is really up to you how you do that. That's the best thing about the commutative law. It doesn't matter which order you do them. Okay, and so the next one is associative law. So the associative law, your numbers can be arranged or associated to make addition and multiplication of 3 or more numbers easier. So remember again, subtraction and division are not associative because order matters for those operations. For example, I've got a set of numbers here that I'm trying to add together. I can arrange them so it's a lot easier. So again, I could even, one of the things I might do is put the 4s together, then the 8, because 2 4s, so 2 4s is 8, and then I might have my 2 plus 3 plus 5 together. So I've got those numbers because that makes 5, and then I might have my 6 and 7. Oh. And so I could make this 16 there. And then I've got a 10 here. And when I've got a 10, then I normally just try and add another number on. So I can be like 16. And look at that, got another 16 already there. Plus the 7. And then I can add those. This is not a hard and fast rule. Like what I'm doing is one strategy. You could be looking for 10s. So you might have gone 8 plus 2, that's 6 and 4, 3 and 7, and that gives us, so that's 1 lot of 10, 2 lot of 10, 3 lot of 10, so that gives us 30, plus 5 plus 4 is 9, and that gives us the same answer. So lots of different strategies, finding one that works for you. So using or exploiting those associative and commutative laws to help you solve problems mentally. Alright, so using associative law with multiplication. Now, it's up to you how you're going to break it up. I'll talk you through one of my mental strategies. This is why it's important to know your number facts so that you can utilize what's the best use of numbers for you. So I can see there's 2 lots of 5s here, so that could potentially help us out with and a 2. So there's some 10s I can handle. So I've got 4 and 5. 4 times 5 equals 20. I've got 5 times 5. 5 times 2. Equals 10. I can take those 2 numbers and the 8 and then rewrite this as I'll write it over here. 8 times 20 times 10 equals, and I'm going to actually take, say, these 2, because 8 and 2, so double 8 is 16 with an extra 0, times 10, and anything multiplied by 10, add another 0. So that is my answer. So that is a mental strategy. You might have even gone 25, doubled that, becomes 50, 50 times 4, so that's 5 times 4 is 20, and then add another 0, so that's 200, 200 times 8, and then you would get 1600. So there's lots of different ways. It doesn't matter which way you associate the numbers. You just need to make sure that your mathematics is right. Okay, and the last one, and this one's a little bit tricky, but it actually is one of the most useful ones that you can use in not only working with integers, so whole numbers, but also with later on, if you've got a good solid understanding of the distributive law, you'll do really well when you come across algebra. Okay, so let's have a look at the examples here. So let's distribute using sums and differences. So the first one here is 17 times 12. This is already a little, 12s are fine, but you might find that you might want to break up your 12 into different number facts. So say 10 plus 2, you'd have 6 plus 6, or say maybe 3 plus 9. But we're multiplying by 17, so if you add 17 times, I would use your 10 plus 2. And then that way, what you're saying is that is 17 multiplied by 10 plus 2. So we'll talk about orders of operations because you would do that in your brackets. That would make 12. Then it would be multiplied by 17. So now you can actually do the 17 times 10, 17 times 2, and then add them together, and you're still going to get the same answer. So I'm just going to change my pen to red. So to make sure that everything gets multiplied by 17, I use what they call crab clause. So 17 times 10, anything multiplied by 10 is a 0 in the end, plus, so making sure I multiply the 2 by the 17, and double, and multiplying by 2 is a double, so that becomes 34. Now I can add those two values together, 402, I have 204. So let's look at this one here as maybe using differences. So you could break your numbers up into, you could use your commutative law and maybe go 9 times 18 and then find your facts of 18, but I'm going to leave it as 18 times 9, as 9 can be found by using the difference of two numbers. So 10 minus 1, getting excited, I do that a lot. I get excited and I write the answer before I get to that point. So 10 minus 1 equals 9. I can use that in here for 9. So I can put the value in. So this value can go in place of the 9. So that would become, I'm going to do that back in my normal color. So equals 18 multiplied bracket 10 minus 1, and then I use my crab clause. Just so I know what they are. And here we go. So 18 times 10, 180, and 18 times 1 is 18, but it's a positive number multiplied by negative gives us a negative. And then I would use my mental strategies to help me out here. Minus 18, so we could go round this up to 20. So you would go like 180 minus 20 gives us 160, and then subtract 2 from that. So minus 2 gives us 158. Oh, sorry, add 2 to the sort. It's because you added, you already subtracted, you need to add 2. And so that would be 160. It's going to give us 162 because I added 2 here. And then you have 162. Righto. So that is some of your mental strategies. There are plenty more. You're not limited to what I'm telling you. It is up to you to explore those. We'll go through that more in detail in class, and there might be a strategy that you're not familiar with that someone else is doing. Okay guys, sorry it's a bit long. Hopefully all good. Cheers, bye.